All right. I just got my Micro PA50 ordered off at AliExpress. And I just want to give you a quick run through about it. So this is a RF sensing activated PA. Doesn't have a signal line. Has a ACC ACC connection, which for either um, uh, two different types of radios you can connect it to it, and it will sense the bands you're on and automatically switch to the bands. It has the filters inside and relays, or you can manually change it by, let's see if I can focus, pushing on this button, the function button 3 times. So it's right now it's on 80 meters. Now it's on 40 meters. So it's pretty that simple. In the back, it came with this cable with no connectors on the end. I added power poles because that's what I have set up. It has a fuse in line on the power side. It has a fan that kicks on when it starts to transmit, and it tells you to keep the SWR below 2. One thing about this is it has some type of circuit protection and an alarm that when the output power goes above 50 watts, I might be 55 watts, but when it goes too high, it turns the PA off from amplifying your signal anymore, and it has a constant alarm, and you have to push the function button to mute it. So anything above even 5 watts, 5 watts is too much. You'll have an output greater than 59 watts with 5 watts. So you'll have to turn the power down. With half a watt, I was able to get out 10 watts. So it doesn't need much. So that is basically the amplifier. There's different function buttons. It depends on how many times you press them, what they'll do. I'm not sure what they all are yet. I just got it. I'm just doing a quick overview. And then next is to test harmonics. All right. I apologize for my setup, but I just want to do a quick test on my Micro PA50. I just got in. It took about a little bit under 2 weeks to get it shipped over from China, from AliExpress. So I was really interested in see if this was clean. So I wanted to check the harmonics. So here's my setup. So I got the PA here, and in the back of it, got a cable going to the transceiver. It's a true usdx. I'm going to be testing 80 meter band. And then out of the PA, the other is into basically 2 attenuators in series, 40 each for a total of 80. And then that goes into my TinySA. So I'm going to show you what you need to do harmonics. You go to measure. Fat fingered it. Let's go back. Measure harmonics. Then you want to put in your frequency. So it's going to be 3.560 megahertz. And so I have a USB powering the true SDX. So the maximum is half a watt, and we're able to manage to get out almost 10 watts on my previous tests through the PA. And the I'll let you see what the harmonics looks like. All right, it's pretty clean. So I have to use my the TinySA app to screen capture these results, and then I'll show you the results for the other bands. I'm only able to test 20, 40, and 80 with this transceiver, but everything looks clean so far. Okay, so we need to know the emission standards for part 97. So for transmitters or external power amplifiers operating below 30 megahertz, you need to have the harmonic suppression at least negative 43 dBs. So that's for all the harmonics of the fundamental. All right, so here is the graph of the harmonics of the 20 meter band. As you can see, the fundamental, we have a signal at negative 37.219 dB. And then the first fundamental is at marker 1 at negative 86. And the second fundamental is at negative 88. And as you go further on, they just decrease and decrease. So that is greater than the negative 43 dB. It's actually negative 48, so we're good there. For 40 meters, it looks even better. We have negative 55 dBm when you look at the difference between the fundamental frequency and the harmonics. Next, we have 80 meter band. The 80 meter band was pretty similar. We had a negative 56 dB of suppression when you look at the difference between the fundamental frequency signal strength and the harmonic signal strength. So for my test so far, this PA is clean, harmonics are good, and it's legal to operate under the Part 97 FCC rules.